Good morning and welcome to today's class. In today's class, we shall be looking at trigonometry 1. At the end of today's class, learners should be able to solve problems involving use of sine, cosine, and tangent in right angles triangles, as well as to derive trigonometric ratios of special angles 30 degrees, 45 degrees, and 60 degrees. At the end of today's class, you should be able to also learn how to apply the use of trigonometrical ratios of 45 degrees, 30 degrees, and 60 degrees to solving problems without the use of calculating aids. Also, the fourth objective will teach us how to relate sine and cosine ratios to the unit circle. In today's class, we shall be taking the basic subheadings. Under trigonometric ratio, we shall look at basic trigonometric ratios of sine, cosine, and tangent with respect to a right-angled triangles. We shall also deal with trigonometric ratios of special angles 30 degrees, 45 degrees, and 60 degrees. In this lecture, we shall also look at the application of trigonometrical ratios to special angles to solve simple problems, and thereafter trigonometric ratios related to the unit circle. Let's look at the basic trigonometric ratios, which are the sine theta, cosine theta, and tangent theta. Before we look at the basic trigonometric ratios, let's understand a triangle. In a right angle triangle, we have three sides and three angles. Let's call this angle alpha. With respect to angle theta, line AC is said to be the opposite side of this angle, while line BC is said to be the hypotenuse side. Hypotenuse side in the sense that it happens to be the longest side of the right angle triangle, as well as the side facing the angle 90 degrees. Also, with respect to angle theta degrees, line AB becomes the adjacent side because this becomes the opposite. If this is the opposite, this is the hypotenuse, then AB, which is the third side, is said to be the adjacent side. While with respect to angle alpha, side AB will now be said to be the opposite side to angle theta degrees because it is the side that is just facing angle alpha degrees. While sine AB is said to be the adjacent side with respect to angle theta, as hypotenuse side is said to be a constant and does not change in that right angle triangle. So long as the angle 90 degrees is not changing its position, the hypotenuse side remains where it is, and it happens to be the longest side in any right angle triangle. So back to the basic trigonometric ratios. We have been able to identify the three sides of a right angle triangle and the included angles. The sine theta is said to be the ratio of the opposite side to the hypotenuse side, and it is said to be a sine theta. While cosine theta is said to be the ratio of the adjacent side to the hypotenuse side, while tan theta is also said to be the ratio of the opposite side to the adjacent side. So in any right angle triangle, the ratio between the opposite side to the hypotenuse side is said to be the sine of that angle theta, while the ratio of the adjacent side to the hypotenuse side gives us the cosine theta of that right angle triangle, while the tangent is said to be the ratio of the opposite side to the adjacent side of that right angle triangle. Let's take some examples. In example 1, we are asked to find the sine, cosine, and tangent of the following angles using trigonometrical tables. Now we shall be making use of the trigonometrical tables to find the sine theta, cos theta, and tan theta of these various angles. For sine 41 degree, all you need to do is to open your sine table, and this is our sine table. For us to get sine 41 degrees is said to be, now if you look at the table, you have value of x, where x is said to be the angles. So we have x running from angle 0 to angle 45, as well as from angle 45 to angle 89 on the other side. Now we are asked to find angle 41 degrees. If you look at the table, we have angle 41 degree here, and all you need to do is look for angle 41 under 0, because this is said to be 40 degrees. That's 40, you can call it 40.0, and 40.0 is said to be 40 under 0. If it is 41, then you are going to check for 40 under 1. Okay, so subsequently we shall learn how to use the sine table, but for today's class I'm going to look at angle 41 degrees, and angle 41 degrees is said to be 0.6561. So this is our angle 41 degrees, which is this 0.6561. So angle 41 degrees is said to be 0.6561. You also look for sine 62 degrees. Go back to your table and you have sine 62 degrees. Still under the sine table, sine 62 degrees is said to be on this column. Now fold trace under x and you see 62. So 62 under 0 is said to be 0.8829. That means sine 62 is said to be 0.8829. This gives us 0.8829. That is to say that the ratio of the opposite side to the hypotenuse side when the angle is 62 degrees is said to be 0.8829. Also, we then asked to find sine 22.5. Now, because this has a fractional part, we are going to look for 22 under 5. So, going back to your sine table, you have 22 under 5. This becomes, we are going to look for 22 under 5. That is 22.5 now. So when you trace it, this gives us 0.4305. So this is 0.4305. And the last but not the least, we are asked to find the sine of angle 81.3. Going back to your table, you are going to look for 81 under 3. And if you trace it, this is 81 under, this is under 0, under 1, under 2, under 3. 81 under 3 is said to be 0.9885. So this gives us 0.9885. So this is sine theta for the various angles. We shall also look for cos theta. Now we are done with the sine theta. We shall then look out for the cosine of each of these angles. So we begin with cosine 41. You then go to your trig table of cos theta and check out what is the value for cos 41. So this is the cosine table. We shall then get the value for cos 41. When you zoom in, this is cos 41, and cos 41 under 0 is said to be 0.7547. So this is 0.7547. We shall then look for the cosine for angle 62 degrees. Going back there, for angle 62 degrees, we have it here, which is 0.4695. So this is 0.4695, while for angle 22.5 degrees, we shall then go to the cosine table and source for 22 under 5. When you go there, 22 under 5, angle 22 is somewhere here. So if you look at 22, so we read 22 under 5. This is under 0, under 1, 2, 3, 4, 5. So 22 under 5 is said to be 0.9239. That is 0.9239. While for angle 81.3, we shall then source for the value of cos 81.3 when we look at 81 under 3. So 81 under 3 gives us, let's go to 81 under 3. This is 81. 81 under 3 is going to be, this is under 0, 1, 2, 3. Under 3 is said to be 0.1167. 0.1167. So this is your value using your trig table. We shall then use the tan table to get the values of all these angles. So we shall begin with angle 41. Angle 41, we are asked to find the tan of it. So go to your tan table. I have downloaded all these in my template which I'm using, so you can as well do same. So for tan 41 degrees, this is the tan table. Tan 41 under 0 is said to be 0.8693. So this is 0.8693. We'll do same for angle 62 degrees. Angle 62 degrees falls somewhere here. Angle 62 degrees is said to be 1.881. So this is said to be 1.881, while tan 22.5, you then check for 22 under 5. So this is 22. 22 under 0, 1, 2, 3, 4, 5 gives us 0.4142. So this is 0.4142, while tan 81.3 will give us 81.3. This is 0, 1, 2, 3 is said to be 6.535. So we have it as 6.535. Now, what this means is that the ratio of the opposite side to the hypotenuse side when the angle theta is 41 degrees is said to be 0.6561, while that of cos is said to be 0.7547, and that of tan is said to be 0.8693. This gives you the relationship between any two sides of a right angle triangle and an included angle. So this is what it means, and we are able to get this using the trigonometrical tables. You can download the trigonometrical tables from either the internet, or you can check at the back of any mathematical textbooks and you find them there. So using tables, this is what you will get. Kindly like our videos as you watch, while we recommend you to subscribe to our channel if you are yet to do so. Use the comment section to interact with us. You can also share the link with your friends and family so that they can also benefit from this class. Example 2 says, we should calculate the remaining angles of the right-angled triangle ABC in the figure below. In triangle ABC, the side AB has been given, while the side AC and BC are also given. None of the angles is given, so we are asked to find these angles. But we have been told that there is a relationship between any two sides of the right angle triangle as well as the included angle. So if we are to find theta degrees, we have already established a fact that sine theta is given to be the ratio of the opposite side to the hypotenuse side, while cos theta is said to be the ratio of the adjacent side to the hypotenuse side, and tan theta is said to be the ratio of the opposite side to the adjacent side. So you can use any of these three relationships to find the included angle because all three sides are given. So I'm going to use the relationship of the sine to get my angles. So I have it that sine theta is said to be equal to opposite over hypotenuse, and with relation to the angle theta, 6 cm or side AC is said to be the opposite side. So this is 6 divided by, while the hypotenuse side measures 10 centimeters. If sine theta is said to be equal to 6 over 10, what will be my angle theta? Now, theta is said to be the sine inverse of the ratio 6 over 10, and using your calculator or using your anti-log table, you can get the value of theta. So using your calculator, if you punch the sine inverse of 6 over 10, it's going to give you an angle 36.8698, which you can approximate to 2 decimal places to be 36.87 degrees. So this is the value of angle theta. Now, if angle theta is said to be 36.87 degrees, we already know that the sum of angles in a right angle triangle is said to be 180 degrees. So if this is 90 degrees and this is 36.83 degrees, we can then get our angle alpha degrees. Our alpha can also be gotten using the trig ratios. Whichever way you go about it gives you the same answer. So I'm going to use the sum of angles in a triangle in getting that. For I know that 90 plus 36.87 plus angle alpha is said to be equal to 180 degrees. Reason is that we have it that sum of angles in a triangle. This is one of the laws. So when you solve for alpha by summing up this, we have it to be, this is going to give us 126.87 degrees plus angle alpha is equals to 180 degrees. So alpha is said to be equal to 180 degrees minus 126.87 degrees, and our alpha is equal to 53.13 degrees. So this is the value of our alpha, which is 53.13 degrees, and this is how it is being solved. You can also use any of the relationships I have listed here in solving for angle alpha, but this way is also possible. Example 3, that in the figure below, we should calculate the angle Z and the values of X and Y. By looking at this question, angle XYZ is said to be a right angle triangle. If this is angle 90 degrees, then it therefore means that this angle here is said to be angle 50 degrees, because if this is 90, this is 40, this is going to be 50. For the sum of angles in triangle XYT is going to give us 180 degrees, and it is only when angle X is 50 degrees that this will be 180 degrees. If angle YXZ is 90 degrees and this alone is 50 degrees, it therefore means that this other side is said to be 40 degrees. And if this is 40 degrees, then automatically angle Z is said to be 50 degrees, because sum of angles in a right angle triangle gives us 180 degrees. So with this, we have been able to get angle Z to be equal to 50 degrees. Reason: sum of angles in a right angle triangle. Now we are asked to find side y and side z, and this place is said to be 8 centimeters. Side yz is given to be 8 centimeters. So if this is the case, in order for us to find y and z, we must first of all get at least a side of triangle xtz. So knowing fully well that side xt is common to both triangle xyt and triangle xzt, we shall use triangle xyt to get side xt, and then in turn look for our y and x. So using the trig ratio, I'll have it that the ratio with reference to angle 40 degrees, the ratio of the opposite side to the hypotenuse side is said to be equal to sine 40 degrees. If opposite over hypotenuse is equal to sine 40 degrees, the opposite side of 40 degrees is said to be side xt. So the ratio of xt to the hypotenuse, which is 8, is said to be equal to sine 40 degrees. And when you cross multiply, you have it that xt, side xt, is equal to 8 sine 40 degrees. Without the use of calculator, you can get the value of sine 40 degrees by looking at your trig table. When you go to your trig table, sine 40 degrees, look at it here, is said to be 0.6428. So this is said to be x times 0.6428. So multiplying this gives us our value of xt. Multiplying 0.6428 by 8 is said to be equal to 5.1424. So our length xt is said to be 5.1424 centimeters. But remember, we are asked to find x and y, side x and y. So we can then use this to get our values for x and y. With the trig ratio, we still have it that side xt to y is said to be sine 50 degrees with respect to angle 50 degrees. So we have already gotten our xt to be equal to 5.1424. So I will substitute this to be 5.1424 divided by y is equal to sine 50 degrees, and when you cross multiply, you have it that y is equals to 5.1424 divided by sine 50 degrees. You can also go back to your log table to get the value of sine 50 degrees, or you can just do direct input into your calculator and it gives you your value. So y is equal to 5.1424 divided by sine 50. Going back to your table, you have sine 50 under 0 to be 0.7660, 0.7660. So when you divide, it gives you your value for y. That is to say that y is equals to 6.7129 centimeters. So this is your value for y. Now, in order for us to get our value for x, we shall also use one of the trig ratios that involve x, either x and y or x and side xt. So this is equal to the ratio of the opposite side to the adjacent side is said to be tan with respect to 50 degrees. So I'll have it that tan 50 degrees is equal to the ratio of xt to side x. Now when you substitute, you have it that tan 50 is equal to xt is already given to be 5.1424 divided by x. Making x the subject of the formula by cross multiplying and dividing, you have it that x is equal to 5.1424 divided by tan 50 degrees. Now you use your tan table to get the value of tan 50. This becomes x is equal to 5.1424 divided by tan 50 under 0 is said to be 1.192. So we have it that this is 1.192. When you divide 5.1424 by 1.192, it gives us the value of x. When you divide this, you will have 4.314 centimeters. So approximately, this is what you will get as your answer. So we have gotten our value for y to be 6.7129 to 4 decimal places, and to 3 decimal places, our value for x is said to be 4.314 centimeters. That brings us to the end of today's class. In today's class, we have been able to solve problems involving the use of sine, cosine, and tangent in a right-angled triangle. In our next class, we shall take the second objective, which is to derive trigonometric ratios of special angles 30 degrees, 45 degrees, and 60 degrees. Kindly like our videos as you watch. We also encourage you to subscribe to this channel if you are yet to do so. Also share the link with your friends and families so that they too can also benefit from this project. Thank you and see you in our next class.